Next, I'm gonna have some work with the floors, okay? You can say farsh in Urdu. Floors can be of different types. There can be floors of tiles. There can be stone chips in the floor. Okay, the floor can be of PCC one. The floor can even be RCC. Okay, just you can say for the factories. Okay, because there we may have heavy load, so RCC floors are constructed. Okay, and so on. You can say etc. Okay, so floor can be of different types, and because of that, the analysis can be different. Okay, however, we will have just an example to clear the idea. We will not spend much time on each floor type. Okay, so let's move ahead and let's say if we have the same very simple, okay, let's say this is the section of a floor whose area is just 30 square meter. This is the total area. You can consider a room maybe, which is actually like AB, okay? Now A times B, that is actually the same thing as 30 square meter. So the section is given and we are asked to calculate materials for the given floor section. Now, subbase, you can see subbase is actually brick ballast, and then we have base is concrete, which is actually 136, and the topping that is actually cement and then stone chip, and that is 1:3. We have already covered the concrete, which is 136. However, we have not yet covered about the stone chips. Okay, so topping, that is very important, in the brick pillars. Let's just move ahead toward the solution. And in the solution, as you can see, the brick ballast can be which is in the subbase, and that can be actually in terms of volume. Okay, and if you remember, we have already covered volumes in the second lecture. Okay, this is the reason I have covered those things, area and volume. Now, what should be the volume? The cross-sectional area or maybe the top area times the thickness. Area is given, okay? The total area, or you can say the total floor area, that is just 30 square meter. And then we will multiply the same area with the thickness, which is known, and it is 12 centimeters. Okay, so this is the quantity of brick ballast. As you can see, we have the total floor area, okay? That is just 30 square meter, you can say. And we will multiply that with the thickness, which is 12 centimeter, or you can say 0.12 meters. Because if you see 1 meter, that is just the same thing as 100 centimeters. Okay. So in order to convert centimeters into meters, you have to divide that by, you can say 100 centimeters. Okay. So we have 12 centimeters. It means 12 by 100, which is the same thing as 0.12. That's why we have 30 times 0.12. Okay, multiply these two, we should have the brick ballast in the subbase maybe, and that is actually 3.6 cubic meter, okay, which is a huge video, cubic meter, because the floor is very wide. It is 30 square meter, maybe like a hall, okay, it is a huge hall, you can say. Now, you may have question about the compaction factor. Like maybe if we have thickness, like let's say if this is floor and if we have 10 centimeter thickness, now after compaction, the thickness may decrease to 8 centimeters, maybe 5 centimeters. So why I'm not taking that? Because we don't compact brick ballast, okay? This is the reason I'm not including the compaction factor. Because if you compact brick balanced, they may become very small, okay, and weak. So this is the reason. As you can see, we have the subbase, and in the subbase, we have actually the concrete work, which is 136. Now, 136 or maybe the concrete work should be actually 30, which is the total area of the floor, and again times 12 centimeter, okay? This is concrete, very simple, or you can say 0.12 meters. Multiply these two, we should have 3.6 cubic meter. Now, it is the same thing as the wet concrete. We have to multiply the wet concrete with 1.54 to convert this into dry, okay? And then from the dry volume, we can calculate cement, sand, and crust stone. It is the same thing as PCC work. So Moving ahead, the material, it is the same formula, okay, just discussed many times in the previous video, so we will not waste our time over here. Now, the cement can be calculated. For the cement, the ratio of material can be taken, okay, which is actually 1, because we have ratio is 1:3:6. In the same ratio, 1 represents the cement ratio, okay? So 1, and we will divide this by the sum up ratio. The sum up ratio means 1 plus 3 plus 6, and that should be actually 10. Okay, so 1 divided by 10 times the dry volume. Now, the dry volume can be very interesting, but we have already just covered it. Okay, that's why I'm not going to spend much time again. The dry volume is actually, you can say, the wet volume times a factor, and that factor is actually 1.54. So we may have the dry volume is 5.544, okay, cubic meters. What's 1.54? We have already just covered that. I'm not going to repeat that again because you guys are not asking me that. It means you are clear about this, okay? So the quantity of cement can be 1 over 10 times the dry volume. It means the quantity of cement should be now 0.5544 cubic meters. Now, this is in cubic meters. You have to convert this into the bags, okay? For that, you should know the volume of one cement bag, which is actually, we're here in Pakistan, that is just 0.035 cubic meters. Very simple, okay? So divide that by 8, and it should be 15.8 bags. You can say 16 bags, okay, for the same floor. Now, the sand can be calculated from the quantity of cement. Now, the quantity of cement that is just 0.5544. Multiply that with the ratio of sand, which is actually 3, and that should be the same thing as 1.66. Now, the crust tone can be calculated. Okay, crust tone that is just known by the Bajri. Okay, in many countries, maybe like Pakistan, Afghanistan, India. Okay, so Bajri is just used for the crust tone or maybe for the coarse aggregates. Now, the quantity of Bajri can be actually the quantity of cement, which is 0.5544, and we will multiply this with the ratio of the crust stone or Bajri, which is 6 in the ratio. Okay, so it is actually the same thing as 3.326 cubic meter. This is it. Very easy. All right, next we have another problem, which is actually the topping. And this is very important in the same topic because we have already covered the subbase base, okay? Subbase and base. That's why I just did it very fast. And however, I'll take some time with the topping, okay? Topping that is just known by the top surface of the floor, you can say, and that is just constructed of the stone chips and cement mixture.